Today we're going to talk about Earth's magnetic fields, and our focus question is how is Earth like a giant magnet? So, our magnetic poles on the Earth wander a bit each year. It's thought that during the Earth's history they have switched a few times, where the magnetism switched from north to south. Last time this happened is predicted about 730,000 years ago. So there's a couple different ways to describe north direction. And the first one is going to be geographic magnetic north. And the Earth rotates on these poles, and this is where the longitude lines converge together or come together at the poles. North and south are directly opposite of each other. The other way to describe north is through a true magnetic north. And when you describe true magnetic north, you can kind of think of Earth as one big bar magnet. The northern lines of attraction enter the Earth here, and a compass will align itself with Earth's magnetic field. The difference between the two norths is about 500 kilometers or 310 miles. This is close to the distance of the drive from New Orleans, Louisiana to Houston, Texas. So you'll notice that magnetic north and geographic north pole are slightly different, that true north and the geographic north. This doesn't seem like it would be that big of a deal, but if you live in some place that's closer to these two norths, for instance in Alaska, you have to be able to compensate for those, especially when using a compass for orienteering or using a compass to get around. This can really throw off your directions if you're very close to them and they are that far apart from each other. So how does the outer core influence the Earth's magnetism? So the Earth consists of a solid iron core. Surrounding this is the outer core that's composed of a hot liquid metal, like we talked about yesterday. The liquid metal that flows in Earth's core creates electrical currents, and this in turn creates our magnetic field. The magnetic field provides a type of protection for the Earth against solar winds, and it can also repel or attract certain materials around in the solar system. So to switch gears a little bit, let's talk about what a compass is. They're used to show direction, and any metal that is magnetized can be used as a compass. This is actually something you could create at home using any metal that can be magnetized as well as a fluid area for it to be able to rotate in. So, like we said, Earth is like a magnet. Earth is really similar to a bar magnet, but it's almost kind of reverse, and this is why a compass points north. It's attracted to the south part of the magnet because the opposites attract in magnets. So when you're using a compass, you want it to be attracted to the south part or the opposite so that it will point you in the northern direction. So if you were to look at this, you'll see that the North Pole is at the south end of the bar magnet, and the South Pole is at the north end of the bar magnet. Also notice the difference between magnetic North Pole and the geographic North Pole. So when we look at this, we kind of see that north is kind of south when we're talking about this bar magnet idea and Earth's electric magnetic field. So once again, you see in the north, there is the south end of the magnet. And in the south, there's a north end of the magnet. And then you have this magnetic field surrounding the Earth, just like in this picture here, where you see it spiral out. Same idea here. Go ahead and move on to your worksheet for the day. When you're done with that, you may move on to your exit ticket.